Hi, welcome back to another class with Domo Math and Science. In this lesson, we'll continue with our lesson on moment of a force. In our previous lessons, we introduced the moment of a force and also used an example to solve questions relating to moment of a force. In this lesson, we'll see how to convert units into SI units and also see how to identify clockwise and anti-clockwise forces when calculating moment of a force. That said, let's get started. The example we have today says that in the diagram above, what will be the force at C if the length of the uniform bar is 1 meter and the center of gravity is at O? The weight of the bar acts at O and it's a uniform bar. Let's redraw this bar. Now, if this is my bar here, obviously the weight of the bar or the mass is concentrated at the center and we've been told is 140 kg. And we've been told that the length of the bar is 1 meters long. So the length of the bar AB, here is A and here is what? Is B. The bar is sitting on two edges. Let's tag these two edges. Here's point D and here's point C. Now we're going to take the moment about D while there's a force acting. We're interested in the force acting at C. We're going to take the moment about D and calculate the force acting at C. Yes, let's tag that force FR. Now there's a weight. Let's get back to the diagram. Okay, there's a weight of 50 newtons. If you look at this diagram carefully, you see that from the center O to this point here we have 30 centimeters. And from this center O, since it's a uniform bar, to the edge A here, we should have 50 centimeters. So that obviously for this force 50 newton, we're left to the perpendicular distance of 20 centimeters, which is the same thing as 0.2 meters. Remember, we're converting from centimeters to meters. So let's replicate that. That means at point A, we have this force here acting between this force and here and the point D, the reference point D, we have 20 centimeter, which is 0.2 meters. And this is a weight of 50 newtons. Now, let's convert our mass into weight. Our mass here says we have 140 kg, and we know that F is equals to mg, which is equals to 140 times 10. That's something as 1,400 newtons. So this is something as 1,400 newtons, 140 newtons. And let's get back to the diagram. We have another weight here for 80 newtons. Now, if the whole length of the rod between A and B is 1 meter, and between 50 and this particular point, D, is 20, that means what I have left between D and here should be what? 80 centimeters, that's 0.8 meters. So I can go back here and replicate this force of 80 newton here. And it has the perpendicular distance between 80 and the point of pivot is 0.8 meters. Now let's calculate the distance for our force FR. Now our force FR is acting directly on top of C, and from this edge, from C to B, we have it as 10. From D to A, we have it as 20. We have it as 20. Obviously, that means we have, if from D to A is 20 meters, and from C to B is 10, then between D and C, what we should have left should be 70 centimeters. That is 20 centimeters plus 70 plus 10. That's 100. So what we have here is 70 centimeters. So that's 0.7 in meters. Let's replicate that. So for this distance, I have it as 0.7 meters. And now let's take the last force. I think the last force is 20 kg, and I can convert 20 kg also to newtons, which will be 20 times 10, which is 200 newton. Let's draw that first. Okay, which is 200 newtons. Then let's calculate the perpendicular distance between the 20 kg and the 20 kg and D. Now, between the 20 kg and the center here, we've been told is 45 centimeter. And between the center and D, we've been told is 30 centimeter. Obviously, between D and my 20 kg, I should have 75 centimeter, which I can easily convert to 0.75 in meters. Now that is between, if I have 20 kg somewhere around here, we've agreed that is 200 newtons. Now for the perpendicular distance, we'll take the perpendicular distance. We've agreed that the perpendicular distance is 0.75 meters. Now let's identify our anticlockwise and clockwise moments. Now A here, my force of 50 Newton around D will definitely produce an anticlockwise movement because it will make this point to turn in an opposite direction to the hand of the clock. That's an anticlockwise. Let's target AC. Now my 1400 newtons, if you look at it with respect to D, it will make the whole body to turn clockwisely. So this is a clockwise movement. 200 with respect to D also will turn clockwisely, is a clockwise moment, while 80 will turn anticlockwise, and FR will also turn anti-clockwise. Now we can now sum up our anticlockwise moments. Anticlockwise moments to be equals to 50 times 0.2 plus 80 times 0.8. That's the distance between the 80 and the point D, and plus my FR will be times 0.7 times 0.7. Now, so that my anticlockwise moment will be given as 50 times 0.2, that's 10, plus 80 times 0.8, that's 64, plus 0.7 FR. Now that's equals to 74 plus 0.7 FR. Now let's calculate our clockwise moment. My clockwise moment, the sum of my clockwise moment will be given as, now for my clockwise moment, I have two C's, that's this and this, that will be given as 1400 times its distance from, I didn't calculate the distance of the 1400. Let's get back to our diagram. That must have been an omission. Okay, it's 30. It's stated it's 30. So that's 30 centimeter. Now here, the perpendicular distance is 30 centimeter. That's 0.3 in meters. Now between here and here, I have 0.3 in meters. That's 140. That's 1400 times 0.3 meters. Plus the other clockwise moment, that's the 200. That's 200 times 0.75. So that this is same thing as my clockwise moment should sum up to 1400 times 0.3 for my calculator. That's 420 plus 200 times 0.75. That's 150, which is equals to 570. Now, if my sum of, remember that for clockwise, for the system to be stable, the sum of anticlockwise moment must equals the sum of my clockwise moment. Permits my handwriting. Then I'll be saying that my 74 plus 0.7 FR is equals to 570. Permit me to remove some of these details so that I can accommodate everything on this page. Okay, finding it difficult to remove those details, let's use another slide. Now I can say that my 714, I can say that my 74 plus 0.7 FR is equals to 570. Is equals to 570. So that 0.7 FR is equals to 570 minus 74. So that FR, 0.7 FR is equals to 496. FR, the first FR is given by 496 over 0.7. So that the reaction at C will be 708.59, which is approximately 709 newtons. 709 newtons. But in our next lesson, we'll start taking a look at moment of an inclined force to the plane. If you are yet to subscribe to our channel, please do not hesitate to hit the subscribe button and do subscribe to our channel. Thank you for staying with us.